Welcome to Module 2, Rational Numbers. Over the next several weeks we'll be working with rational numbers and spending a good deal of time with a few different activities and one game in particular that we will be working with is called the integer game. Okay. And the integer game here is described. I have also placed this this handout, so to say, two-page handout. I've placed it on the website under on the Rational Numbers tab. If you would look there, I also have a video of how to play the integer game. Okay. And that would be good to for you to very handy for you to take a look at and to watch. The integer game, as you can see right here, is a card game used throughout Grade 7 Module 2 to help students develop a conceptual understanding. Okay, to help students. Oopsie daisy, wrong one. Oh boy. To help students develop a conceptual understanding of integer operations. Okay, so it's a handy little game because honestly, despite the fact that it looks all so simple, negatives and positives, it really isn't. It's not something that's very natural to young people. More natural to those of us who have dealt with negative balances in our lives. Negative degrees, temperatures. So anyway, this integer game is a game that hopefully we will use at home as well as in the class, and I have to count on you using it at home. I can't actually see, and in fact, you're going to use it at home first before you use it in class. Anyway, integer game, I'm not going to go over how to play it, but I will tell you right here, as you can see right here, it's designed for 2 to 4 players. Now that's with the little sets of 26 integer cards. There are 2 zeros, and then there's -1 to -12, and then +1 to +12. So those are what's included in a single set. Now I'm going to give everybody, or I have given, depending on when you watch this video, 2 sets. So if you do have a large group at home that you want to play, maybe you could just go ahead and combine those 2 sets. Okay, so with one partner though at home, it should be easy enough just to play with mom and dad, or sister or brother, or a few. Okay, so again, like I said, I will not go into how to play right now. I want you to watch that video. I had planned on actually embedding it in here into this presentation, but I've thought not to. Okay, so here's an integer game. I guess here's some more how to play. Real easy. 4 cards to everybody, and a draw pile and a discard pile, and very familiar. It looks a lot like other games you played. Another thing that they do include on this 2-page handout, which is at the website, like I had mentioned, is how the integer game is used in all of the lessons. Okay, so for example, right now, it's the only time I'll do this, but in lesson 1 right here, which is we're going to kick into, students try to reach a score of 0 by obtaining the same number of positive points as negative points. Okay, and they're trying to get as close to 0. So the idea is that they are applying their knowledge of negative and positive numbers, and again, you'll see in lesson 1 there are other ways to help them do just that. Okay, and you can see it's also appears in lesson 3, 4, 5, and then lesson 10, 11, and 12. Okay, and here's what they look like. The copies, the black line masters that are actually in the children's books. You don't need to pull those out, or the binders. You don't need to pull those out because I'm going to give them some sets on index card stock, a little bit more durable. Okay, so that's those. All right, and there are this idea of scaffolding ideas for diverse learners, okay, for children who need to look at things in a different way. Include a number line representation on the cards if you want to. I mean, you could go ahead and do that. You can see how that might help. Then if it were a negative number, you would put it on the other side of the zero, for example. Okay, you can include counters if you want to get some little counters to put on, and you can see you designate the counters. The negative counters are going to have a different look than a positive counter. Okay, so one thing that'll be really handy while you're working through these problems is a number line. Okay, and we'll take a look at how we'll use a number line. I'll actually scroll back to this page probably a couple of times, but yeah, a number line. I have a number line black line master that I will go ahead and also put at the website. Okay, again in rational numbers. You could also use your grid paper that I had given you at the beginning of this school year to just make sure you have your even separations between your numbers, okay, between your integers. Okay. All right, so here's the lesson. Here's how it starts. It starts out with opposite quantities combine to make 0. Okay, and this is a big idea. Believe it or not, it's becomes a really huge idea later on in algebra as well. So the idea here, exercise 1, positive and negative numbers review. So just trying to look and see what we know about positive and negative numbers. So it says with your partner, and that could be your teacher, your parent teacher, or someone else that's in the nearby vicinity. Use the graphic organizer. You can recognize this is what's called a Venn diagram to record what you know about positive and negative numbers. Add or remove statements during the whole class discussion. There won't be a whole class discussion, but I will go ahead and plug in some things that I'd like to plug in. So, and again, if you're not familiar with the Venn diagram, all the negative number aspects are going to go into here. This side, positive numbers are going to go in here, and then in here is where they are both the same. That's what they have in common. Okay, that's what they have in common. All right, and you might have known that already. Take all that off. Okay, so go ahead and pause and take some time to fill that out in your binder, and then come on back. Okay, so here are some of the points I've made on my Venn diagram here. So in terms of negative numbers over here, and again, a lot of this is pretty basic, and a lot of this many of you know already, but it's worth to go over again and just see how this applies to new information. So negative numbers are to the left of the 0. Okay, when we have a number line, and again we're thinking about a number line. They're to the left of the 0. The value gets smaller as you move to the left, which is one of those aspects of negative numbers, which is quite confusing for kids. So if we just looked at this right here, we have 0. Of course, this is our positive side. Again, we'll get to that again, and then we have our negative side here. Okay, and here's the thing. And honestly, I mean, as much as none of us want to believe it's us, very, very, very often, a child will identify -5 as being greater in value than a -1. Okay, again, because of most of our work on the positive side of the number line. This is where most of what we've done in the past has taken place, has been over here. But as you can see, and if you just always think to yourself about right and left of the 0, that will help you out greatly. Numbers get bigger as you move right, smaller as you move left, and that doesn't matter where you are on the number line. You could be right here on the number line, okay? I move to the left, still your value is going to get smaller. And you move to the right, your value is going to get larger. Okay. Okay, another thing is that they can mean a loss, a decrease. This is negative numbers still. Below 0 in terms of degrees on a thermometer. Below sea level. And they look like this. This -7 down there. You see that -7 and that -3. They look like this. They have to have the negative sign in front of them. Okay? Yeah, that's it for negative numbers. So on the positive number side, there to the right of 0, okay, as we know, to the right of 0, the value gets larger as you move right, okay, and as we talked before, again, the positive as you move towards the right, okay. They can mean a gain, an increase above sea level, above 0 in terms of degrees, and they don't have a sign. Okay, very, very important. Positive numbers don't need any sign. Okay, negative numbers need their sign in front of them to tell us what we're dealing with. Positive numbers don't. In the future, near future, you'll often see when you're working with negative numbers within larger equations, we will put parentheses around them to to show that we're talking about a negative number and not necessarily -7, as in if we had a minus sign, for example. Okay, because this a minus sign says do the opposite. Okay, the negative number sign here just says you're moving to the left if you're on a number line. Okay, so in this case, again, I don't want to confuse you, but these two right here are the same exact thing. Minus a -7 means do the opposite of -7, which would be +7. Okay. Alrighty, so yeah, let's just move on here. We have example 2, counting up and counting down on the number line, and let's just go ahead and talk about this. So counting up on a number line corresponds to positive numbers. Okay, positive numbers, because when we count up, we're going to the right. And it doesn't matter where we count up from. And we can start here at -8. We can count up to -3. We will have actually added a positive. So we've added a +5. Okay? So that's a positive number. It doesn't matter that the result of adding that positive is still a negative. Okay? But it's still, anytime you're moving up or counting up on a number line, you are adding a positive number. Now, counting down, of course, corresponds to negative numbers. And again, we can look over here. If we start from 10, count down to 5, we have still taken away a 5, so we have a -5 here. We've actually, truth is, subtraction doesn't really exist, some will say. The idea is that it is you are adding a negative. Okay, so in this case you've added a -5. Here on the other side you've added a +5. Okay. So over here, the next question, it says, when you where do you begin when locating a number on the number line? Okay, so let's just go ahead and look at this here. Actually, I have this on here already, but let me get that off. One point I'd like to make is that, well, anyway, you can look here, and we have a blank number line. All right. In order for me to find out, for example, let's say on the top number line where -3 is located, the one point I really could use to help me would be the 0. Okay, so I can put the 0 there, and if I know the 0 is there, I just need to count down 1, 2, 3 to the left, and I know I have -3. Okay? 1, 2, 3 to the right, counting up, and I'm at +3. Now the truth is, I mean, on a number line, 0 can be here, could be here, could be over there where we did the first one, or it could not be at all. Okay? A number line, as you see it, and you see it right here, it's a little segment. I mean, it says segment. It has a beginning and ending point like that. It's just a portion of the number line that goes on and on and on and on. Okay? It's infinite in nature, infinitely positive, infinitely negative. Okay? But anyway, yeah, the answer to that question would have been, where do you begin when locating a number? The number line, we'll just say 0, and again, that's for this stage of the game. Okay. Now another, a very important aspect of the algebra we'll be doing coming up is this next idea here, and it says, what do you call the distance between a number and 0 on the number line? Okay. So let's just say we start at 0. And we go up to 10. Okay. We start at 0. And we go down to 10. Okay. Now this distance and this distance are the same. Okay. They are the same. This is 10, and this is 10. Now that's the distance. And again, remember, this is the most important word in all of this idea of distance. If I were a little black ant, okay, here I am, a little black ant. All right, get my body together here, little antenna, some feet. Okay, if I'm an ant, and if I walk this way down the number line, I am walking 10 places. If I walk this way on the number line, I am also walking 10 places. Okay, I am walking 10 units. All right? It doesn't matter which way I go, I am still going the same distance. Now this distance idea has a name, and that name is absolute value. And again, some of you might have been familiar with absolute value. I know some aren't, but hopefully you'll come to understand that better and better. Just remember, absolute value is this idea of distance. Okay? All right. Okay, so here's using the integer game and the number line. All right. Again, the integer game, I have posted some directions, a little instructional video at the website. You could take a look there, how it's played. I'm not going to go over exactly how it's played now, but I just want to show you just a scenario and just tie the integer game to the number line. All right. So in the integer game, everybody gets 4 cards. Okay, as it begins the game. All right. Let's just say here are the 4 cards that we were dealt. Collectively, we were dealt these cards. Okay, and this is the order we were dealt them in. This was our first card. This is our second card. Here's our third card, and here's our fourth card. Now, when you get the cards dealt to you, you might not necessarily deal with it this way, in order as they were dealt to you. But for our purposes right now, we're going to deal with it that way. So we were dealt a 5 first. Okay, we're dealt a 5. And this idea, they're saying, use the counting on method. Okay, so you see that says counting on. Sorry, counting on. Oh my gosh, I'm sorry. I'm just like something is going on with my thing. You probably can't tell, but anyway, the counting on method, and that just means what I'm about to do. So if we have 5. I'm going to start from, where do I start? Yeah, that's right. Start from 0 because I have nothing. I mean, to begin with, I have nothing in my hand. I have no integers, so I have nothing. So that's where I start. I start right here. And from here, I'm going to go 1, 2, 3, 4, 5. Okay? I go 5 to the right because I have a positive 5. How do I know it's positive? I know it's positive because it does not have a negative sign in front of it. Okay? Now, the next card I am dealt is a negative 5. Okay, here's my negative 5 right here with the negative sign in front of it. Alright, so my negative 5 takes me from here, and let's go ahead and do this in red, huh? I go 1, 2, 3, 4, 5. Okay, so now I am back where I started from at 0. Okay, we have another negative. Let's make this in red here too. So another, and then third card is a negative 3. I'm sorry, negative 4. So I'm going to continue to go to the left. 1, 2, 3, 4. And now I am at negative 4. Fourth card is 8. Oops, I should do that. Let's do that in black. Fourth card is 8. And then I go from here and I just go 1, 2, 3, 4, 5, 6, 7, 8. And I end up at 4. Okay? So the final position on the number line is 4. Okay, so I started at 0, went up to 5, went down 5, went down another 4, and then up 8, and I ended up back, or not back, I never was at 4, but I ended up at 4. Okay? So, it asks you right here, it says, what card or combination of cards would you need to get back to 0? So I'd like you to take a look at that and come on back, and I'm going to pause here for a sec. Okay, so the question is, what card or combination of cards would you need to get back to 0? Now, there are, golly gee, a number of answers, okay, a number of combinations. But the truth is you only get 4 turns, okay, but you will have, well actually you will have all of these cards in your hand, so you would have 4 more turns. Well, what card to get back to 0? The first card to get there right away would be negative 4, okay. I'm going to change this up a little bit. Let's do this all over again. I just want to show you just another way to do this if you want to even do something like this. But we can do like just some like little hops. So if we go like that, there's our first, that's our 5, and then we had that negative 5. We could just show that as another hop. Okay, and then we had another negative 4. Another hop, and then we had that big old positive 8, which would have brought us right there. Okay, so that's a nice little hoppers. Okay, so if we were going to do that, we can hop, then again we'd hop negative 4 again right to there. Okay, all right, and that could get us there. But we could have also drawn a negative 1 and then a negative 3, for example, because that's going to get us to 4. Okay, so if we took that well, let's just get those out of there. Let's get that last little hop. Get that one back. Okay. But if we went ahead and did negative 1, then we would move there, and then a negative 3, then we would go there. Okay? So yeah, it's various ways. I mean, you could even do a positive 12 and a negative, well, you can't because we don't have 16, but let's see, a positive 8 and a negative 12. And that would give us, yeah, let's just go ahead and do that. How about that? So, I put a positive 8. Let's watch how that works. Positive 8. Oh, darn, we can't do that either. We'll have 12. Okay. How about a positive 6? Positive 6. Here we go. Remember, we're at 4 right now. Positive 6 would get us to 10. And then a negative 10 will get us to 0. Okay? Lots of different combinations. All right. Next idea here, this next exercise is called the additive inverse. Okay? The additive inverse. What I'd like you to do here is, would you go ahead and try to do this right here on your own. So here, use the number line to answer each of the following questions. Okay, if you notice the way we did it here, some of the things we did before with the number line. All right, so I'm going to have you go ahead and just do these. We'll do these 3 right here, A, B, and C. There are more, but that's on my next page. So you do A, B, and C, and then come on back. Okay, so the first question they ask you is, how far is 7 from 0, and in which direction? Okay, how far is 7 from 0? All right, and we can see that, and we know that from starting at 0, going to 7. Okay, that is of course 1. Well, we know 1, 2, 3, 4, 5, 6, 7. And which direction? Of course, we know because we had no negative sign. We know it's positive, so we know it is in the right direction. Okay, so yeah, so 7 is 7 from 0 in the right, or what would we just say? 7 to the right. I know this seems really simple, but bear with me. So B asks you, what is the opposite of 7? And this is this idea that they are getting to here, and that's this idea, this additive inverse. The opposite of 7, of course, is negative 7. And maybe it's not that obvious. I don't know. Sometimes I'm not quite sure what is obvious and what is not. But the opposite of 7 is negative 7. So now C asks you, how far is negative 7 from 0 and in which direction? We talked about that before. We looked at one example using, I think it was 10 and negative 10 from 0. But yeah, here we go. We have go from 0, start from 0, go to negative 7. And again, we've gone 1, 2, 3, 4, 5, 6, 7. Again, 7. So it is, how far is it? It is 7 to the left. And it's not negative 7 because we're talking about how far is it from 0. It's 7 units. Let's just put units in there too. Put 7 units. We don't really know what these units are. 7 units, and over here would be units as well. Okay, units. I know it looks a little messy, but yeah. So 7 is 7 units from 0, and negative 7 is also 7 units from 0. Okay. All right. So let's look at some of these here. D. This would be on your probably. Yeah, I'm not sure. Still on. No, it's on the next page, I think. Yeah. So thinking back to our previous work, how would you use the counting on method, remember that counting on method, to represent the following? Okay, here we go. This whole idea of representing, you know how important that is with this new standards, okay? Is to how can you use this to represent the following, okay? So while playing the integer game, the first card selected is 7, and the second card selected is -7. So how would you use the counting on method to represent that? And when we talk about counting on method, of course, we're talking about something like that, more like that. Okay, so you go ahead and make your own. Use make a number line maybe in your journal, or just draw a number line here. It's nice to have it nice and neat, though. Please use a ruler if you're going to do it on your binder. Okay, well, yeah, thinking back, I mean, what you would do is, of course, you would start at 0. Let's just go find a blank here. So let's just say start at 0, and you would your first card is 7. So you'd go up 1, 2, 3, 4, 5, 6, 7. My counting on method there. That's 7. And then my second card, okay, I'm going to use red again, is the -7. So 1, 2, 3, 4, 5, 6, 7. Okay? So that would be how I could represent that. I start at 0. Start at 0. Count up to 7 because it's positive, and then count down -7. Okay. Because it is negative. Okay. Looks like I had a disconnection problem. I'm not sure exactly how much of this you saw, but I was counting up. I was counting up 7 because my first card dealt was a 7, and then I counted down 7 because my next card was a -7, and then I ended up at 0. Okie doke. Yeah, so we did those, and let's see, I got the next page here. Hold on one second. I will be back. Okay, I'm sorry again. Some technical difficulty, excuse me. But yeah, we did this one up here. We did D. But now E asks you, what does this tell us about the sum of 7 and its opposite -7? Okay, so if we looked back at what we just did, the sum of 7 and -7, I guess. I know, sorry, I was told this is very confusing, but I am really, really sorry. Let's a summary. Don't want to be doing that. Don't know where I am. There I am right now. Okay. Anyway, let's just cut to the chase here with this one. Okay. 7 and -7. Okay. The sum of -7, or 7 and -7, is 0. Okay. We could write it like this. We could say 7 plus, remember I told you about this, -7 equals 0. Okay, so these two are opposites. All right, they're opposites, and they're also referred to, and I don't think they're going to do this for you here, but they're also referred to as the additive inverse of one another. Okay, additive inverse. Okay. Now F, look at the curved arrows you drew for 7 and -7. What relationship exists between these two arrows that would support your claim about the sum of 7 and -7? So we should probably maybe go back and find a place we can do this on. Okay. Yeah, so here we go. We had our our curves here. So we went from right here, we went to the right, okay, to get our 7. We went to the left to get our -7, okay, and those two right there, they are opposites of each other. Yeah, and if you would take this, if you went on this positive side and you took a -7, you would get back to 0, okay, because you'd be moving to the left. If you're on the negative side and you moved back right 7, positive 7, you'd be back at 0. Okay, they are opposites, or what's also referred to as the additive inverse. Okay. So do you think this will hold true for the sum of any number and its opposite? And the answer is a resounding yes. We don't want to beat that too much. Okay. So here we are. We are at the well, actually, it says exercise 3. It says play the integer game. I would highly recommend you do play it. Play it a couple times, and it is a lot of fun. See if you can actually develop a strategy for it. I'm not quite sure. Haven't played it enough myself to come to that conclusion, but see what you can do. Okay, so let's go ahead and just look at this lesson summary. Add positive integers by counting up and negative integers by counting down. An integer plus its opposite sum is 0. The opposite of a number is called the additive inverse because the two numbers' sum is 0. Okay, and in this case we're talking about numbers. We could talk about other things in the future, and we most likely will. Okay.